Hi everyone, I'm Narmatha, Assistant Professor, working in Dr. S.N.S. Selection College of Arts and Science. So in today's lecture, we are going to discuss about hash function, requirements and attacks. So we already discussed about hash functions. So with that, we'll see about what are all the requirements and attacks happened by using this. Lamport one-time password. So it is like a pass protocol. The example is given here. Alice sends I am Alice. Server sends n minus 1. Alice sends x where x is equals h of n minus 1 of PA. So server verifies h of x is equals h of n PA and server updates to Alice n minus 1 comma x. So attacker still cannot get PA or authenticate as Alice. So what here it means, so we are sending some messages. So that message is sends through server. So server what it does means it verifies whether who is sending and for whom we are sending. So by that server updates the particular person, that person sends to whom, and by using which server it sends. So along with these all these kinds of things, attackers doesn't know about what is the actual message. Two simple insecure hash functions. So consider two simple insecure hash functions bit by bit exclusive OR of every block. So it has a redundancy check for every time and also reasonably effective as data integrity check. Next one is 1-bit circular shift on hash value. For each successive n-bit block, we need to perform rotate current hash value to left by 1 bit and XOR block. So it is good for data integrity but useless for security. So here what we are doing means we are performing two simple insecure hash functions. One is bit by bit XOR operation. For every bit we have to perform XOR operation. So that is one thing. And another simple and secure hash function is 1-bit circular shift. So if we have performed 1 bit means then for the next we have to uh, shift that to 1 bit left. Again we have to perform XOR operation. So it will be rotated based on the blocks what we have. Hash function requirements. So we need these kinds of requirements: variable input size, fixed output size, efficiency, pre-image resistance, second pre-image resistance, collision resistance, pseudo-randomness. So these are all the requirements we should have if we are using hash function means. So variable input size means input size is variable, so we didn't fix the input size. So it can take any kind of data and the size of data. Fixed output size means the output that produced by the hash function should be fixed. So if we have specified 5-bit information means it only should have 5-bit information. Efficiency. So the efficiency of implementing a hash function is very higher and easier to compute and perform the operations. Pre-image resistance means it uses one-way property. So computationally, if we have to perform or we have to get for two different inputs same output or same hash value means that is not possible. So that is the pre-image resistance. Next, second pre-image resistance means finally given block it computationally infeasible. So if both the inputs are same means it doesn't produce the same hash value. Next, collision resistant means if we are using any pair of value means that pair of value will not be equal. Pseudo randomness means the that means that hash value should stand for pseudo randomness. If we are testing, that means it should satisfy that pseudo randomness. So these are all the requirements, main requirements of hash function. So from this lecture, you can understand about how we are performing hash function, and also what are all the requirements that needed for hash functions. Thank you.